Okay. So in 2006, I wanted to do a game version of Astro 1 online. And we found that it wasn't really time yet to be able to have a small team of people, mostly working part-time, to develop a real video game. And instead, we opted for a story-based approach. And so the whole content of our Astro 1 general education class was put into the context of a science fiction story. And we really wanted to allow students, in the story, to explore why astronomy might be relevant to them personally in terms of thinking about their lives, why they're alive, what the purpose of life is, and all of those kinds of questions. We found it to be a better tool than the classroom for those kinds of issues, because you can really go further with fiction than you could standing up in front of a class, attempting to lecture or discuss with them those kinds of things, which are really rather private. The other advantage that we saw was that students, sometimes attend class, so students sometimes actually listen while they're attending class. Here we wanted to set up a vehicle where they more or less had to go through the material, complete various multiple choice questions to reach the end of the different units. And we find a 95% completion rate, that most all the students do read through all the material in some manner, even if they're just guessing the answers to the questions. Still, the responsibility for the learning is really on the student. We check whether they have figured out things by asking them these questions, but we don't really guide them through teaching important concepts step by step. What I want to show you today is our new course, where we really are going to do that and where it is a true video game. The old course has been taken by 7,000 UP students, 1,000 World Campus students or so. It generates a few $100,000 income to our department, which now exceeds any other income to our department, used basically to run the astronomy and astrophysics department. So it's been very successful. Student test averages in the story-based version did go up by 5 to 10% from the lecture version that I taught. I shouldn't say that it's someone else's but it's a better vehicle for me, to teach. And the World Campus students are very fond of the class. It receives very, very high ratings. Now it's really a game. It will be offered for the first time in fall 2013. And what we're going to show you today is the very first premiere of the first unit of the course. The course has 4 units. The first unit is on the basics of the nighttime sky, the seasons, the moon, and light, spectroscopy, and gravity. So those are the topics. And we're going to show you a bit of this here today. And the way that we're going to do this is we've kind of split up who says what kinds of things. And I'm going to run the show, but these guys are going to be interjecting things as well. Because if I have to tell the truth, I didn't really see this until yesterday afternoon. They really put all the pieces together for the sake of this presentation. And we're getting closer and closer to having Unit 1 really done. Yeah.
What tool did you use to create the game? Was it a programming tool like C# or?
Unity 3D.
Unity 3D.
Which I actually primarily program in C#, but
okay.
So that's the code, but the engine is in C++. We don't look at the engine code, but they supply a whole lot of tools that allow the cameras, cameras, collisions, a lot of stuff like that. And so the support, I highly recommend Unity 3D if you're going to do 3D stuff. Their support for 2D isn't quite as good, so if you're looking to do 2D, there may be other engines or frameworks that are better, but for 3D, I think Unity has done a great job.
Okay, thank you.
Yeah, and so Basically, you've been here now quite a while, right?
Almost 3 years.
Almost 3 years, though I would say that the first year was more or less spent. He's an astronomy and physics bachelor's degree person who has trained himself in many aspects of programming and design. And so when all is said and done, I think this product will take about 3 years of FTE effort to produce, just to give an indication. But that wouldn't be possible if my guys weren't both astronomers, because they can do things with the content that someone without that strong problem-solving science background could not do. So I think that's very important in the overall scheme of things. And I keep encouraging the other departments in the College of Science to go that route.
Yeah.
But so far, not too much success in convincing them. But hopefully the product is what will ultimately convince them. There has been a couple of other people involved before we get started. Daryl Branford is part of the online education group in the College of Science, and he has both programming and artistic skills as well, and he has been helping, part-time with this effort, a few hours a week, up to maybe quarter time a week for about a year now. And then Scott Given is a local middle school teacher, and he helped us a great deal with the content development. We do intend to take this course into the middle schools, more or less concurrently, to pilot it with the university course. The level is about the same. The level that is required for middle school is about the same as what's required for gen ed courses at Penn State. So that works to our advantage. Okay, so let me set the stage here. So this is going to be the very beginning of the course. Students have arrived on the surface of Mars. These are the first exchange students who are studying abroad on Mars, and they are Kinsey, the girl here, and Fabian is the difficult one to control. He sometimes gets unruly and dances and things when he doesn't want to. And then this is Rory, and Rory is the character. Andrew has a term for this.
The third person?
Yeah, that's a third-person character that the student taking the course is playing Rory.
Oh, okay.
And there will be a choice as to whether Rory is male or female looking. They're starting out having just landed on the surface. This is in a crater, and the crater is covered with a dome so that there's no difficulty with breathing. That's simplifying costuming issues for our characters. The first topic of interest here is basically, I guess, the dialogue starts to introduce it. So.
Should I go ahead?
Yeah, go ahead.
So the frame rate on the Adobe Connect looks to be a little slow, so it looks like it might be a little choppy, but I'll just keep playing and hopefully it doesn't look too bad.
There also might be a little bit of a delay.
Yeah, that's what, I'll watch my screen instead.
So Knox, do you want to summarize the
Sure,
dialogue?
so I realize it's a little pixely up there and difficult to read, but the idea is that they've just arrived on Mars after a long journey from Earth, and so the first thing that the main character pretends to notice, putting you in the first person, in the main character's shoes, is that the gravity is different. You step off the spaceship and you feel lighter on your feet, and so you can talk to the other characters, and the main character can ask, what's going on here. And of course, they've sort of been training for this exchange program all along the way, but it's not really until you arrive there that it really hits you. And so the fellow there refers the main character to handheld devices they're all carrying as their mobile encyclopedia guide to the Martian colony, Mars colony. And in it, is kind of some of the content we'll be presenting laid out in kind of a traditional format. We just call this the encyclopedia, but you can, the student playing this game will read through this, but then there'll be opportunities to actually apply some of these principles and really kind of see how these expressions are derived by deriving it themselves through a bit of practice.
So it's a redundant presentation. We will make sure that everything is traditionally presented as well, so that those who feel very uncomfortable with this will have something that they can go to and refer to. But all that we really expect them to know and understand deeply will be drilled through very interactive, very pedagogical kinds of tools.
So part of this is, there's the futuristic setting, which is, makes it easier in some ways to present a lot of materials, particularly things we'll get to in later years, like how to plausibly explore the other planets in the solar system in person, how to travel to other stars. And part of that is putting it in a futuristic setting, but also having these students having access to a virtual reality lab, which is too difficult to read the dialogue there, but that's what they end up saying is, oh, I know, we can, figure out what's going on here by going down to the virtual reality lab, and maybe we can set up a simulation to explore the background of gravity. So
It looks a lot like a Sims game, but at one point you said they could choose which question to ask. So do you have multiple paths that they could take, or?
So the questions are, so there's a big dialogue engine, and we can do that if we want.
Right.
For now, what we have it as is just asking them questions that, for that part specifically, the questions don't matter. It's just to kind of get them to answer
Just to
something.
make it interactive? Okay.
Yeah. Now, there are questions that we'll get to after the first lesson that we're going to show,
Okay.
where it's actually asking questions, and if you get it wrong, it says, no, have you thought about this? And then
Okay,
they get the same question again. So, yeah, we can do
Cool.
either one. The
Yeah.
questions that are more story-based, that are kind of like, oh, we're on Mars, what do you think of that?
Right.
They don't really
Right,
have an
they're not
impact.
really a
Yeah,
big
it's just,
long,
it kind of
yeah.
goes, and then it comes back to where the
Okay.
story is.
Okay.
But when it comes to some of the other stuff, we do have that interactivity where if they get it wrong, we can guide them a little bit better.
Cool, nice. That's
And,
great.
in this little group of, of classmates here, some of those other mechanics questions are just a way for the student playing this to kind of inject a bit of their own
Right,
personality in there.
yeah. Good idea.
And, if the other two characters are, having a discussion, you can jump in there and, support one argument or another.
There's nobody else in class with that same person, though? It's just them and then your animated characters, or can someone else control another character in your same game?
Oh,
Okay.
it's
That's what I thought, okay.
player.
Yeah, single player, yeah. Okay.
No, we operate with 800 students at once. But there will be leaderboards for games and things like that, not for games that require studying and intellectual ability, but for things that are reflex games combined with that, where it's really chance who's at the top or the amount of time that you spend. But the grade does not depend upon the leaderboard.
So we've transitioned from the underground, the larger underground section to the virtual reality lab that they'll be using. And so what we have here is the computer, they walk up to it, and then they get a selection. Now when the game starts, the only selection choice will be the platformer game, the gravity game that Knox was talking about. But we just have this open like this because we're going to get into the rest of them just to show you glimpses of what's going on with them. But for now, we'll start with the gravity game. So what happens is for each one, you get a specific item that shows up so you know where to go, then it'll launch into the game when you interact with that. So, and then Jane, if you want to, as I
Okay.
go along.
So, the Gravity game actually begins with teaching as opposed to, with games. And, the first thing is saying, just familiarizing them with the tool. This is about how high an average person can jump on the Earth. In the simulator, you jump the same height every time. Because of this, we'll see that any increase in gravity decreases the jump height by that factor, and vice versa. Jump to the second platform when you're ready.
Cool.
So Andrew's going to go ahead and jump.
The jumping, I promise it looks a lot smoother on my
Oh,
screen.
yeah.
I just realized that it's not too smooth on
No,
the
it's fine.
What happens if we change the mass of the planet you're jumping on? Let's increase it to 2 times the mass of the Earth. And then it's asking how high you're jumping. So here's the Earth and how high, and here's 2 times the mass.
And like I said, with the jumping not being as smooth, it's really hard to see the difference, but as you can see, it's...
Yeah, I could switch the projector.
It's okay. I can show you guys later if you want to see
See,
a little
it's
bit
half
better.
as high.
It's just
or
half
twice
as high, yeah.
Okay. Half as high, yeah.
Okay? And of course, if you're wrong, it does
Yeah.
other things.
Yeah, actually, I can do that here. So now we change the mass to half the mass of the Earth. How much higher are you jumping? If we do half as high here, it just says
Right.
incorrect. Now we've changed the mass.
Okay.
It just asks the question again. So
Cool. Then the layer appears.
And then if the mass is 0.25, then you jump 4 times higher. So now it is just asking you to kind of summarize what you've just learned and choose as the mass increases the jump height. And is it increases or decreases?
sorry, I already answered it.
Good, and you answered correctly. Now we're going to explore what happens if we change the radius of the planet without changing the mass.
Cool.
So we keep mass as Earth's mass, change the radius to half of the radius of Earth. There's Earth's mass. Here is
Hard to see. Sorry.
half, and it's obviously not very much. Oh, it really isn't. Yeah, it's because of the
It's
flood.
Yeah, that's what I was.
The
Yeah,
jerkiness is making it hard to tell, but trust us, it all.
So what's the
Yeah.
answer? So that one was a quarter,
Quarter.
and then so for now we're on 2 times, and you can see it's significantly higher than twice as high. So
Right.
it's
Right.
So you see that the radius is more important, basically, in determining this.
and then
And so they go on and experiment more.
Yeah, here you can see with the jump, it's significantly high, so it's way higher. The platform isn't visible there when it's at the top, so.
So when the radius is 3 times, the jump height is 9 times.
Sort of like watching the 10-meter platform at the Olympics.
And so then it's actually telling you the jump height decreases as increases as the square of the radius, yes. Okay, and so then it's asking them, what the relationship is, to kind of come up with that. And at that point, we will lead them through plugging some numbers into that relationship step by step. And in the course of that, we will explain, what is Mars's mass and radius, Moon, and Jupiter, and come up with the numbers that are written up here for the game. In this game, I guess Andrew's going to tell you about the game
Sure.
itself.
Sure. So, if they want more practice with the concept, the math, and getting used to that, they can redo the dialogue section that we just did. But this game part is more to get them used to the idea of different gravities and the effects of how much higher you would jump, and to get them just to see what the differences are between Earth, Mars, the Moon, and Jupiter. And so to illustrate that, what we do is I've set these platforms at differing heights, specifically designed for one or the other of these gravities. And so I'll go through, I've played this many times trying to debug the code, so I've gotten pretty good at it. But the idea is you see that this is a really big jump, and you're on Mars gravity, but that's not going to work. Jupiter is 3 times the Earth, so you're clearly not going to make that. So then it must be the Moon, and so you can jump, and that, okay, so that cleared it. And so the idea is to, the first couple of times you go through, to get an idea of what each jump is, and kind of go through a little bit more slowly. Well, then there's another thing you can figure out, which is, well, I can just use the Moon every time and just keep jumping, but what we've done is pause the controller so that they can't move if they fall too far, so they can't use the Moon every time. So we've kind of put in a penalty for just sticking on the Moon, so that they kind of have to play around with the different gravities. So if I use the Moon here, see if it does it.
Cool.
Yeah. But yeah, so if you fall too far, it pauses the controller so you can't move. So it gives them an incentive to actually try the different gravities and to play around with it. And so again, this isn't going to get them better at the math, but I think by doing this, it gives them a better sense of what happens with gravity. So in different gravities, you jump at different heights. What does that mean? When the radius is much smaller, or even, especially the one I find the most interesting is Jupiter, because it's so much more massive than the Earth that you think, it's easy to think that the gravity is going to be, hundreds of times bigger or 10 times bigger than the Earth. But because the radius is also so large and the radius is squared, the gravity at the surface, if you could stand on the surface of Jupiter, is actually only 3 times more. And so just to give them those numbers, to get them used to the idea of what's going on there. So we'll go back to the lab, and I'll come back to...
And the clock is running there, so again, there's potential for a score.
So, are you collecting data for students as they go through these different pieces?
Not yet.
Okay.
I'm hoping to be able to get some... I know there are... there's code that... I don't think Unity has any specifically, but people have designed so that you can get metrics. And actually, I know the guys at Unity were talking about doing some in-engine stuff with metrics, but it's something we really want. It's a matter of time, whether we have the time to implement that and what kind of data we can get. It's something I'm considering, though.
And they will get credit for completing certain things. We won't be...
Oh, right.
Yeah.
Sorry. I should, let me clarify that, actually.
Yeah.
So I was thinking more in terms of really, really specific metrics.
Right.
But what we will have is, essentially there will be a save file, and the save file will be a really long binary file so that they can't change it easily. They don't know what bits to change. And they will have to submit that to us, and I'll have something that'll check whether or not. And there'll be a bunch of dummy bits so that if they change something, it screws it up, and we know they tampered with it. But anyway, so the idea is we will be able to check how far along they've gotten, and that will be for participation purposes, things like that. But in terms of more specific metrics, like where people struggle and things like that, I'd like to do that. I'm not sure if we can yet. We'll see. But yeah, we will keep track of progress. That part is guaranteed to be in the first version of the course. So.
And you were talking about having a traditional way of going through the course. Is that something you guys are going to be checking as well and see which students opt into the game and which ones don't?
Well, no, it's not
maybe
exactly like that. Even within the game version, there will be in each segment, and we're more or less through. Well, we have a post-test kind of thing we're going to show you in a moment, but we're more or less through the gravity part of it, having skipped over some aspects of that. You read the stuff in the encyclopedia, or skim over it if you're not the kind of student who likes that sort of thing. You play, you do the tutorial, you play the game, and then you're done. You do the post-test, right? And so in every case, you have that, and you have that encyclopedia that you can then refer back to. You're kidding me. I have to play the game every time I want to see it. They say this about the story version sometimes. Not many of them. It's 12% that don't like the story version that take that online. But the way that we really solve this is that we will have always running Astro One lecture, many sections, Astro One web, which is the story-based, and then Astro One video game.
Oh, cool.
The story-based may disappear at some point, but will always have to be kept at some level for accessibility.
Right.
It will always have to exist, at some level and be ready for, conversion for whatever student might need it. So far, we really haven't had anyone who's needed it, but.
So would there be an option where they could do different pieces of any of those?
No.
Okay, so they would
No.
have to choose.
Their
track.
instructor is teaching whichever version, and so, yeah, they have to choose when they register.
Okay.
And I have been thinking about how we're going to handle that, as to what that, how to accommodate that decision, because it's just listed as a section,
Oh, right.
right? And so if you click on that section, then you get an ad for what's going to be that you're going to see. But it's going to be a little bit confusing to people, and we will try to help them adjust at the beginning of the semester
Yeah.
quickly into the one that's right for them or that they think would be right for them. But we're trying to put in features into this game version that will appeal to a broad audience. So, for example, there will be diary entries of sorts that characters in the game are writing. If you care about the storyline, which kind of starts out as a confrontation between someone kind of living in a fiction, fantasy-driven world, just really loves to explore what could be, and then kind of a realist. One of the characters is just, we're on Mars, let's, develop Mars the best we can, let's explore Mars and learn as much as we can about it. The other one's always in the virtual lab playing games. And those two have a friction between them. We don't want to torture students who really don't care with that, so we will be adding in optional things. But that might appeal to a different group of students. I mean, the hope is that this will be as appealing as a novel in terms of the plot line that someone would have open to them. And the possibility will also exist to write as your own character your thoughts about what's going on in the plot. So that being particularly appealing for middle school because of incorporating writing assignments in a science class and kind of broadening that out. But we digress. Here they just left the gravity game, and a robot walks up to them, and this robot kind of appears at inopportune moments when they don't really want him to, and starts to ask them questions. It's kind of a comical aspect to things, and then these questions that the robot will ask will be very similar to the questions I currently ask in my course. And a certain fraction of the test will be taken exactly from these questions, word for word, and the students will be told that that is the case. And, in this way, we will learn, to some degree how effective is this compared to the other one. But we'll also be able to ask much more difficult questions that are related to the logic taught in the games. So the test will be harder, but we'll keep the averages at around 80, 75 at the lowest. That's where I like my averages for morale.
So you are the robot. In some ways.
Yeah.
Or the robot is you.
And you appear at inopportune moments.
Did you say about how else they'll access the robot?
No, I
Okay.
didn't. Go ahead.
Okay, so the other thing is, so the idea is for the robot to come up to them after the lessons, and we'll have scripted questions to reinforce the specific things we want them to learn, or the specific things that are most important. But they will also be able to access the robot essentially at any time. He'll be in a certain location, and they'll go up to him, and he'll say, "Hi, what do you want to do?" And whatever lessons they've done so far, they will have review questions for that lesson that will include the ones they've already gotten, as well as some other ones for that. So that will be a way that they can get to review, especially right before the exam, whatever units they've done will already, or whatever sections they've done will already be open, and so they'll be able to go through those with him and earn points and things like that. So he'll be available for review almost pretty much at any time.
We skip over those questions, we're not gonna make you answer them.
Yeah, I figured it would be too hard to read them, so.
Yeah.
But it's kind of a narrative break between chapters, that can run back to the dorm block. And from time to time, there'll be other scenes that are not lesson-based, they're just story, but story development between the main character and the other characters, and this is where you could, write the diary entries and things like that.
Not that my wife would be taking the course, but one thing I'm looking at is that she always gets lost in these kinds of games. Do you guys have a plan for like a little map or something
Yeah.
to show?
So, oh yeah, actually, we plan, the map is something we plan to do for sure. Right now, what we have, let me turn around, I can show you. We have these lights, like the blue lights there, and then the green ones that were on the other side. So we try and make the lights guide you to a specific section, so that you don't have to refer to the map as much, and hopefully once you get used to it, you won't. But we do plan, the map, I've actually implemented it on the Surface when we had an old Surface. So it's not programmatically that difficult. I did have one before, so it will be in there, yeah. We definitely don't want them getting lost.
Yeah, and they've been told to follow the lights, the blue lights
gotcha.
specifically, so.
Gotcha. Okay.
And if anyone has trouble, then we add features to the don't.
Mm-hmm.
That's the way it works in my old course too. I don't get any questions. In fact, even from the very beginning, we got very few. Because if there's any problem, let's remove that problem. If there's a question that they can't do, let's get rid of the question. That's the end of that. So that makes it easier to go on to bigger and better things. You don't have to waste your time and give people frustration. Frustration is the worst thing in online classes.
Yeah, and with gaming, sometimes, I mean, there are certain games where the idea is to get them a little stuck and have them explore. We don't want to do that just because the idea is for them to get through all of the material. So we'll be doing pretty much everything we can to make sure they know exactly where they need to go. The mini-map will have the objectives that they're supposed to have next. There will be a quest log that tells you, okay, you should be going here next, that kind of thing. So yeah, the idea is that, like not said with the breaks in between them, they will have the ability to explore. If they really want to get into this and check out the nooks and crannies that we've put into these locations, they can. But yeah, we certainly don't want to have them running across the map every time just for the sake of it.
And, it was hard to see the dialogue but in the spots, but when you finish sort of a dialogue set of your next goal, and if you put the game down and come back to it later and you forget, you can also ask any of the characters and they'll remind you whatever you just did last or where they're expecting you to go next. Cool.
So we've left the underground section to go into the big buildings you saw on the side of the cliff there, which are it's the dorm building. So now we're going to leave the other side of that to go into the actual dorm room for the character. And this one is first person, so you can see around your own dorm room. It's rather sparse right now. We'll have it more decorated in the future, but we just wanted to give you an idea of most of the locations we'll have on the Martian colony. So we've got the dorm room, the dorm building, the underground, the above ground, and then the lab, which we'll get back to now. We won't run across there. We'll just bring it back up.
Decorating the room is something that we've also discussed, and earning points to purchase specific things to decorate the room, which will appeal to a different set of people.
Well, I could see students trading like screenshots of their room, it's kind of like, hey, look around,
Yeah, and then especially with the middle school, but the college students soon will be the ones who grew up with Webkin's World, so,
Yeah.
that's, part of what we have in mind as well. So now what we want to do is just quickly show you, 5 of the other parts, but just very quickly. And so first, we go into the seasons, and Knox, would you motivate why we're doing this in the storyline?
Sure, so again, it's a reflection by some of the characters of, what's different in Mars, what are they having to adjust to, and one of them is the temperature outside. Even though they've got kind of a microclimate enclosed, it's notably colder all the time. Now, the colony is supposed to be situated about where the equator is, so there aren't really seasons exactly, but they don't know that. The main character just asks, why am I cold all the time, when's it going to be summer? And that opens up a discussion of the seasons, the origin of the seasons on Earth, which, as it turns out, has everything to do with the Earth's tilt in relation to the sun, or in relation to the plane in which it orbits the sun. And in this case, rather than a 3D game we've built in-house, this is a tool that we can use that's already available online. And one of the strengths of this kind of applet is that this can be up on the desktop alongside the game. So as the dialogue is progressing in the game, as the teacher or one of the characters is talking, the students can actually manipulate the tool, and when a question comes up, it's not, okay, did you catch that earlier? You can manipulate the dials on here and actually find the answer to that question then, which presumably drives the lesson home a little easier. And here, again, just as an example, we've got a planet orbiting the sun, and this little image here shows the angle, the sunlight hitting the surface, and the sort of a reflection in the thermometer next to it. I'm just going to speed this up a bit so the contrast is a little more noticeable. But you can see that for someone who's located at that X mark on the planet, when they're tilted away from the sun, it's cooler, that's winter time, and when they're tilted towards it, it's summertime. And one of the questions is, well, what's the situation for Mars then? As it happens, Mars actually has about the same tilt as the Earth does, but if this colony were situated on Venus, or a planet like that, Venus actually has very little or no tilt at all, and so there really aren't seasons of any particular note there. At the other extreme, you'd have something like the planet Uranus, which is pretty well tipped on its side, and as it goes around, if you can catch it, the temperature variations on a planet with such extreme tilt are very high. Now, the actual planet Uranus is very far from the sun, so it's like Mars, it's farther from Earth, or farther from the sun than the Earth is, so it's cold all the time. But the point here is that the tilt of the planet, and this is the take on lesson for this whole section, is that the tilt of the planet has more to do with seasonal variations than, say, its changing distance from the sun over the course of a year. And this is just one of a few of these type of applets where the strength of it is that you can actually manipulate the thing while you're being asked questions, find your answers that way.
Now, is that free to use, or did you have to ask permission to use it, or?
We're linking to it,
You just
so
want
the
to
students can link to it.
It's out there for
And
anyone.
there are alternative tools that can quickly be swapped in if that website disappears. That's the way we've operated for 6 years, and everyone says, you know, that's such a big deal. It's not a big deal. Like, once a semester, something kind of suddenly disappears, you quickly swap in something else, change a little wording, and you're done. And that's not worth going through all the torture that people seem to think that you need to go through.
And to be clear, most of those links are from NASA or other universities or other public-facing people. So they're applets that are usually going to be around for a while, and they're usually welcoming of other people using them.
Yeah, I saw that it was McGraw-Hill, and I thought something was a company, and then that maybe they'd be like...
Yeah, that one was a little bit different, but there are similar options, so, yeah. So, you know, by leading them through these tools, though, as part of our own stories, it won't be really noticeable that, oh, that's a link and this isn't a link. You know, it should be fairly clear. Then we go on to the phases of the moon. We're going to have to go a little more rapidly than we had planned through this. But this is one of the two concepts in this unit students have the most difficulty with, because it requires spatial reasoning that is really beyond what most of these folks are used to thinking about. And typically what they do now is memorize things. And we just accept that. We're not going to accept that anymore. We're going to really try. And I know from having them sitting in my office and doing this with them, I know how to do it, and this is really doing that.
So to introduce what's going on here, first we talk about, we get them used to the mechanics of the Earth and the Moon. So the Earth rotates. We show them what a day is like, show them it rotate once. We show that the Moon moves a little bit each day, but doesn't necessarily change its phase every day. And then we go through and get them used to how much it moves in a day, how much it moves in a month, that it goes through all of its phases in about 1 month. Give them the names of the phases, and then we let them play around and let them move the Moon on their own. And then after that, we get into the phases. So what we do is we show the full moon, and then we leave the Moon up here so they can see what they're doing. And what they have to do is stop the Moon in that phase and check. So then they check, that was correct. So next we move on to the new moon, and so the moon as it would appear during the day if it were visible. So then this time we don't leave the moon in the upper right, and they have to match it, so they have to get used to what those are. And so what we do is we give them a little bit of information and then have them come up with everything on their own, instead of just giving them the chart, which seems to be the way it happens now in a lot of lectures, because you can't sit and derive it with each student. And so we go through each of the phases. We go through the quarters, and I won't go through all of them, but I'm going to go through the quarters because right after the quarters I want to show. So what we do is we guide them through a question. So this is, what we're asking is how much of the total surface of the moon is illuminated in the third quarter. So no matter which place you're looking at, whether you're looking at where you're supposed to be looking, which is here for the total surface, or if you're looking at the third quarter, the answer is 50%. But what we ask next is for the full moon, and so we take the moon away in the upper right, and hopefully they understand that they're supposed to be looking at the moon as it appears by itself, not as it appears from Earth. So we're trying to get them to understand that the moon is always half illuminated by the sun, as you can see on the left. So no matter where you go, it's always half illuminated. The reason for the lunar phases is the way they see it from the Earth. So we ask these questions kind of in between, and so we try and get them to understand why the phases exist, and so we go through all the phases, and then after the phases we have a game that essentially has them randomly get each phase. I will show you that in a moment in a more complicated version, which also includes what I'm going to go through here, and like Jane said, we don't have as much time, so I'm just going to go through it real quick.
This was even hard for me, this part, so we're not going to try to teach you this part right now.
So this is, in addition to just the names of the phases, this is teaching them when you can expect a phase to be overhead, and when you can expect a phase to be rising and setting, how you can predict when a phase will be in the sky. And so this is real science. This is using what you know to predict things. And so this is them deriving that science, so going through it themselves. Now, this is the game I was talking about, and what we have here is, to start, there's only one button, just play and stop. And the idea is to get them to stop in a phase that they know. So stop it in the new moon first, then we have them stop it on the full moon, and it gets them used to the scoring, which I've done. So essentially, each answer is a phase of the moon, and the phases are defined by, so 0 and 180 for the full and new moon, 90 and 270 for the quarters, and then in between for gibbous and the crescent. And what happens is, if you're right on that degree mark, you get the full point. For every degree you're off, you get a few points off if you're in the same phase. And so the idea is for them to stop it in the right. So it's a little bit arcadey, but it's also, they have to have the right answer.
You know, the tickets come out of your computer and you take them to your instructor to receive a higher grade.
And so in the original version, it's just 10 questions about phases. So it randomly gives them a phase and they have to stop it in that phase. And it doesn't ask the same phase consecutively. And then, but this version has the more complex questions. So it starts with name this phase for 3 questions. Then it's which phase will be overhead at this time, these questions. So it gets more and more, progressively more complicated. And so this is a way, this is more so than the gravity game. This is a game that has a little bit of game element, but it's actually asking them the questions as they go. So they could use this as a review tool if they wanted. Now they would still have the option of using just regular questions if they wanted as well. So we'll go back to the lab now, and go to the constellation.
So this next part is a part that Knox has developed, which is sort of a simulated planetarium in a virtual reality lab. And, you know, if you just, now let's keep this at 30 seconds, Knox.
Well, in this case, it's like a planetarium you can freely walk about in rather than sit there and have it explained to you and kind of, you'll have to take my word for it or watch it move slowly. It's a planetarium where your character essentially takes the role of an observer on Earth, and you can walk around. So we have a sky globe and a path that represents the Earth's orbit, and you can walk along it, essentially traversing a year's time, and see where the sun, maybe look up to your left. Yeah. So where the sun falls against the background stars. And we get into just a discussion of what the constellations are, why they come about. You know, it's a matter of our point of view on the Earth, and then the origin of concepts like the zodiac, that, you know, it's just this set of constellations that happen to fall along the sun's path.
And leading people through that, you know, step by step, again, with questions at every moment that they try something. Okay, so let's click out of that. And go on to light. Yeah, on light it's similar to seasons in that we found a tool we liked, and so we're just going to be using that tool to have them adjust the frequency of the wave and learn how the wavelength of the light changes with frequency. Answer questions about that. You have to lose it.
Yeah, no.
No end, yeah, you got it, okay.
One of the strengths of this kind of thing, again, is like the seasons one, is there can be questions in the game alongside this that you have to stop. You can actually hit the pause button, and with those rulers there, make a measurement and actually derive the relation between the wavelength and the frequency and how that relates to the energy of the wave. It's the kind of thing that in a classroom you can actually have someone come up and demonstrate, and you can definitely see that it takes more energy to create a higher frequency wave.
So they're going to learn about infrared, ultraviolet, X-ray, all of the different types of radiation, and the little gamey gimmick is going to be a drill for if power is lost in the colony, in the underground colony, and they're going to have to make their way to the surface wearing infrared goggles, and so we're going to change the appearance of the colony and make bodies light up from their heat when you wear the glasses, and then make your way out as a little kind of reward in between little parts. And then we go into the spectroscopy, This is the hardest concept for students. It's very abstract for them, but it's no more abstract than games that a lot of them play. And they're able to do that, so I'm sure they're able to do this. And this has, again, kind of like the gravity pedagogical tools, where you adjust the temperature, you try to match the spectrum up here with to the spectrum down here by adjusting the temperature, and then you get these dark lines in the spectrum. We want to show atom by atom how these lines arise, and so they have to click in there to see their energy levels, and then they have to move the electron. They're told to move it from one level to the other, and when they do that, the line appears up there in the appropriate place. And we lead them through that step by step. For each of the lines in the spectrum, we'll have 3 different chemical elements, and we show what happens to the photons as they're absorbed. This is asking what particle is being absorbed, because we don't want them to just think it's a little dot. They have to know what it is to play the game. They have to know what is being absorbed and what is jumping, because they are always telling me, well, that thing is moving and something's energies are changing, but they've not ever thought through it once what's actually happening. They're just words they've tried to memorize. We're trying to combat that. Yeah.
And to clarify, so the way we want, or the way this will work in the course, we've sort of jumped around through a lot of these things, but the way we want it to work in the course is they get an introduction to the topic in the dialogue that we showed you. Then they come into the game and they have to learn it through the tool, so they start using the tool. Then they play the game, which reinforces that. And that's where, and so we interrupt the tool with those questions, but even before that, we're teaching them through the dialogue, getting them used to the terminology, and sometimes sending them to either the encyclopedia or another web page in order for them to get used to the topic before we throw them straight into the game. And so they will have multiple different ways to look at the material, so it's not just going to be one or the other. We'll have a lot of resources for them. It won't just be one type. So.
But also a very uniform pattern,
right,
as to what they expect in each part of this thing. So the game in this is a conveyor belt that comes in with the different kind of spectra. Students have to match as many of those as possible within a certain length of time by manipulating the atoms. And so again, you know, speed for fun, if you want to do that. So this whole part also, or this whole unit also has a theme that they're gradually collecting parts to make a telescope, that they're going to build on Mars and they're going to assemble it. We're going to have an assembly scene, and they're going to use it to look at certain stars to see that stars are different colors, which is, you know, we're reinforcing our whole deal about light and the different colors of light. And then that telescope will be basically a functioning telescope, a functioning simulated telescope that will be used throughout the rest of the course, where they can enter in coordinates of an object. The telescope moves to that place, and they can see what you'd see through a small telescope looking in that direction, and then they can link to the encyclopedia that will show a picture that the Hubble or some large telescope has taken of that same object to get a feel for that. So we'll come back to that again and again. And that's basically the first quarter of this thing. The other quarters will work in different scenes. Mars is the home base, but there will be a scene where they explore a simulated solar system, where they can move from one planet to another within the virtual reality lab, explore the surfaces of those planets the best that we know what the surfaces of those planets look like at the moment. They will be able to go out into the galaxy, look at different stars, look at the planetary systems around those stars, plot those stars on a complicated diagram that no one ever understands, but they'll have to plot them one by one on there, see the pattern in that diagram. That'll lead them through. And then they go off and see distant galaxies, and they even go back into the history of time, and they change something that happened early in time and see how the universe comes out differently at the end. but they've actually been, sort of, played with by an alien from a different parallel universe in another dimension that has those properties. He wants to talk them into changing our universe, but in the end they decide that sort of the vulnerability of life in our universe is part of what it's all about, and kind of come around to a message of some sort. So that having been said, this is where we're at now, and we hope that, parts of it are done that you didn't see because we skipped past them, but I think we're on pace to make this happen for fall. We have to be. Tell my department head we are, and and hopefully it will really work well.
We're still after one. I wanted to ask if anyone on the phone had any questions. Okay. Mary, did
It's okay. No questions. Thank you for the presentation.
Thank you. Were there any questions here?
Yeah, the graphics are awesome, the game is good,
We'd love to be able to, like, get in there and play with it.
Yeah, when it's
We have
not,
to
is
take
there
your
any
course to do that.
possibility?
Oh, yeah, it's, I hope it's completely open. That's what I would like to do. That's a very controversial point. The last version, my college would not permit me to give it to anyone to use it for anything. Other departments, though, have been, leaving theirs as open courseware. And I kind of, said, we were sitting around the table, the other departments, and I was the associate dean, and I said, well, okay, so I guess I can put mine out there now. And she's like, she doesn't want me to. I want, my goal is not just making money. My goal is that as many people see astronomy as possible. To get course credit, you have to pay. I get that, but mostly it's for astronomy, and then, a next goal is for Penn State, but I don't know how this is all going to shake up, but we intend to use it for middle schools at any rate. There the challenge will be, the resources to get people to adopt it. And I'm not interested in campaigning for that. I mean, that would be a disastrous use of my career, to have to go from school to school and district to district. And, maybe the product will speak for itself to some degree. I don't know, but that's where we're at right now.
I did have one question, which is, what kind of strategies would you recommend if someone wanted to build a course around a narrative like this?
I would start with the story approach like we did originally. The budget for that was $40,000, and the time scale for that could be as short as 6 months with, an interested group of people working on it. Templates can be provided by Knox, that people can fill in, and physics is actually using that now. You use that then to make enough money for your department to invest in more. And then you look for the faculty member in your department, a postdoc that doesn't have a job, that is interested, that wants to stay around for another year, a graduate student who wants a career in this area, an undergrad that's just graduating and wants to, you look for the person that really wants to do this, and you hire them. And then it happens. And that's what you do. You don't force someone who doesn't want to develop an online course, who doesn't think online courses could be effective or ever be as good as anything else. You don't worry about forcing them into it. You find the people that want to do it, and you try not to penalize them for doing it, and then I think you're good, you know.
Is there any lecture at all, or is it all reading of that encyclopedia?
Absolutely no lecture.
Okay. So it's all reading and playing the games and doing the quizzes and problem solving?
And on UP campus, the Tester and Pollock Testing Center, there's no opportunity to cheat.
Oh, okay.
Yeah.
Harold,
So-
correct me. Story templates, how can we get a hold of them?
She'll have to actually meet with us, and we'll
Okay.
have to show her how that,
Okay.
would work. They're not user-friendly, they're easy to use, but they're not user-friendly, right? They're our templates that we use for our course, and so if someone has a little bit in the way of resources and needs, like, extra help beyond a couple hours, Knox is available for overtime.
Yeah.
Well, seriously, he's not paying enough, and those guys have no travel budget. Our department's not able to provide that, so he's available for overtime, like I said.
Okay.
Any other questions?
I have a question not related to this. Do you guys use the Microsoft Research Worldwide Telescope? Do you know what that is?
Not exactly. I know there are various,
Yeah, just curious.
yeah, we haven't yet,
Okay.
but we should.
Yeah,
I've heard
I
of
can
it.
send a link to somebody if you want to check it out.
Okay.
It's pretty cool, yeah.
Yeah.
It just sounds like it might fit in a little bit here somewhere, so.
Right, because
Yeah.
I mean, half of our stuff is going to be made by us, and half of
Yeah.
the stuff is not.
Yeah.
And we pick the best stuff that's not,
Yeah.
and then we do what we have to do to fill in the gaps. And we intentionally wanted to be sure that as you go through the course, that it's an equal fraction of those things, so it doesn't evolve like it looks like, oh, at the end, you don't, you know, you didn't do as much work, or at the beginning, the last course, at the beginning, we didn't do as much work. We were really strapped for time
Yeah.
when we were teaching it and writing it as we went along. This time, we intend to be in better shape and kind of, we want to leave this unit behind within a month and set it aside, and work on the next unit.
Yeah.
So have it fully functional, but the things like, you know, the different paths,
Mm-hmm.
we can add in paths,
Sure, yeah.
you know, the
yeah.
storyline paths.
Yeah.
We can always add those in.
Yeah.
Knox is
Yeah.
really good at writing that stuff, and,
All right, I'm gonna stop recording, which I think might disconnect the phone. Are there any questions before I do the?
Oh, yeah, Yanni,
From
Yanni Lynn,
Lynn,
Yanni
you
Lynn,
see it, like it's blinking, the yellow?
in the chat. There you go.
Okay.
Okay.
All right. All right, thanks, everyone. We'll be meeting again next month, and it'll be about the mineral hunting, so.
Who?
Yeah.
Mineral hunt.
Middle
That's a good one.
Elizabeth, can I
Thanks
send
a
you
lot.
that link to the guys? Or?
Sure.
Hi.
Found
Okay.
another
I
thing.
brought my
Bye.
little one,
Thank you.
the Astro Fest.
Excellent job, guys.
It kind of
Very
reminds me
nice.
of the one room where you had them playing like a game and stuff. Is that-
Well,
Yeah.
this is where it comes in fun.
Okay. Yeah.